Rockets are made up of a lot of systems.
An engine system, a main propulsion system, a communication system.
There's parachutes, there's avionics, there's electric cabling, miles and miles and miles of it.
So many different parts and so many different pieces.
Well over 1 million parts on the launch vehicle.
You know, in a house you've got plumbing, in a house you've got wiring, you've got structures. Well, our house has to fly.
Engineers are all about solving problems. That's really our job title, is solving problems and making something useful. My job is a system engineer, and that basically means that I'm responsible, and the people that work with me are responsible for making sure that this extremely complex launch vehicle all works together.
I'm an integration project engineer. Part of being an integrator is to make sure that the system works as a whole. You have a lot of individual components that, when they work by themselves, that's great, but they need to work all together for a successful vehicle.
One of the things we do in engineering is to create models. This is one of our performance analysis design demonstrators. Fancy word for an engineering model. Here's one of the locations, potential locations for that electrical interface.
Okay,
And let
great.
me come around here and show you a couple of things that we're thinking about for the...
I work on the upper stage of the Ares 1 project. My job is to be sure that all the little pieces to build the rocket fit together.
You can do models with different types of construction techniques. We've chosen for this model to use plywood and 2x4s and PVC pipe and foam board and things like that. This is a mock-up of our inner stage, the piece of structure that connects the first stage of the Ares launch vehicle with the upper stage of the Ares launch vehicle. When Ares is on the launch pad, there will be ground crew that will have to come into this space.
People down at Kennedy Space Center, they're going to have to work on it. They're going to have to be able to go inside the vehicle. Did we leave enough room for somebody in there connecting cables?
The J2X engine is represented by that center section of our mock-up. The exterior volume of that engine bell is represented by our PVC pipes. It gives us the ability to take a look at the size and shape and volume of this J2X engine in relationship to all the other pieces of equipment in the inner stage. The engine is an extremely complex piece of machinery, and it requires a lot of equipment to make sure that it can run and to operate safely.
It's such a huge task, but if you break it down into the parts and just deal with them one thing at a time, then it's doable.
That's right behind us on the door here, when we moved it from inside 90 degrees.
That's great.
We're sitting in our collaborative engineering and design analysis room. Technology has come a long way between the time we designed Space Shuttle and what we're doing now with the Ares vehicle. All of our designers now are designing their parts in the virtual world. They are actually designing three-dimensional virtual parts.
Here at Marshall Space Flight Center, we take those parts and put as many as we can together to build a virtual mock-up of the vehicle. We take it and begin to analyze it. We can go in and actually fly through the vehicle. Basically, from a click of a mouse, I can go anywhere on the vehicle.
Roosevelt, can you fly us up into that frustrum region? And let's go take a look at that joint. We have the ability to do three-dimensional projection. We have special glasses that we put on so we can really get a sense of the size and shape and volume associated with all these various parts. We can actually go inside the fuel tank, take a look at how things are put in there. Go take a look at our instrument unit where all of our flight computers and navigation equipment is. See if there's a better location for things.
We can see where interferences are.
Seeing that that everything's going to match up the way it's supposed to. The last thing we want to happen is for all these pieces to get shipped and get down there to stack the Ares 1 and find out something doesn't fit together. You know, we have to find those things out long before the vehicle ever ends up at Kennedy Space Center.
Building a launch vehicle or any other integrated system requires teamwork.
We have design teams literally spread across the country.
There are thousands and thousands of people that work on and support the Ares vehicle.
You have to have all those people involved in all those groups and all those teams because we're all important. We're all part of that same big team with one goal in mind, and that's for manned spaceflight.
There's tremendous opportunities that you do not have to be an expert in everything to work in the space industry. The folks that I like to try to recruit just out of college to work with me are the ones that are extremely innovative, extremely creative, but have a very good foundation in traditional science and the traditional math.
Something that you have to be able to do is be courageous enough to ask the question. Not everybody knows all the answers, and it's really hard when you're brand new on a project and you're the only girl in the room and everybody else has 20, 30 years on you. Being able to say, I don't understand, or this doesn't make sense. And the worst thing that can happen is you're wrong and somebody will explain it to you and you learn something new, or you're right and we're missing something, and we've now solved a problem because you offer a different perspective.
For the student that's in 10th grade, I would tell them there are many avenues in the space industry that are just limitless.